Hello, everyone. Happy Saturday. Welcome to the fourth Saturday of the month, our science and technology call, specifically with Dr. Harmon and myself. We are going to take a deep dive into 4 of Lifewave's clinical studies. Now, if you're familiar with Lifewave, or maybe if you're a guest today, Lifewave as a company is a technology that David Schmidt, the inventor of the technology, the owner, CEO of our company, has created actually 20 years ago. And so over the last 20 years, he has invented a dozen different patches. And of course, each patch has a different purpose. Today, Dr. Harmon and I are going to take a deep dive into 4 clinical studies. Now, over the last 20 years, many doctors, scientists, labs, and researchers, including David, have done over 90 clinical studies, many double-blind, placebo, from independent labs, like I said, all over the globe. We are open in 81 countries. But we're just going to touch on 4 today. And Dr. Harmon has so graciously created these amazing slides, PowerPoints for you. And so after our research and dive into them, we have come up with this information that he has put on the slides. So we're going to go ahead and get started right away. Like I said, grab your notebooks, grab your pens, and Dr. Harmon, let's get started.
All right. Thank you very much, Dr. Staci. I had the pleasure of meeting her in person last year in the shuttle going from Cancun to the Hilton Riviera Tulum on the Lifewave trip. And I got to feel her energy, her tenderness as she spoke about her daughter, and to meet her husband, Brent, and my wife, Carla, and I enjoyed that trip so much. And I would also like to thank her for reaching out 2 months ago. And she said, hey, we should do a webinar about some of these studies. I said, that's a great idea. And so we made a little pact, and it was her task to dig through the studies, print them, highlight them, send them back to me, what she thought were the key points that we needed to touch, and to put them in an understandable format. Not that we're so smart, it's just, it's technical, and we would be equally confused to listen to, somebody in your industry talk your industry. So before I get started, I do want to say a couple of things. One, this is intended for information only. Nothing that Dr. Staci and I will be talking about is intended to treat, recommend a treatment, diagnose, make an assessment, a protocol, or anything related to treating diseases or disorders. That is not what this is intended to do. And I would also I would not recommend that this recording link be sent out to new people as a first exposure to Lifewave. There's a lot of information, and it may be overwhelming. You'll be able to have the recording. You can go back and listen to things, and it is our deepest desire. We want to give you an even greater conviction about how groundbreaking this technology is, and to get that. Once you have that, you'll want to go forth and achieve that goal that David Schmidt said, and that was to bring this technology into 1 billion homes. I want you to know that I'm committed to that goal. And once we reach that, we'll just move on to the next billion. That's what I think. All right, well, let's get started. We got 4 studies. Let's see. Dr. Staci, you'll need to give me a screen sharing capability, please.
You got it.
Okay. All right. I love this first slide. What do you want to be when you get older? Younger. One of my goals my whole life since I was about 40 is that I have 2 main goals. I want to remember who I am when I'm old, and I don't want to be meeting a new person in my house every 15 minutes who happens to be my wife. And these patches go right along with that. The Lifewave Research and Studies, Dr. Staci Holweger, Senior Presidential Director. Folks, you can't get any higher than that. And myself, Dr. John Harmon. I'm not at that senior presidential yet, but I am working on it. Today, we want to spark some new areas of the brain and have your brain secrete that stuff that it does when it's making new neurons. And we want you to look at these things a little bit different, a little bit deeper. We're talking about the first study I'm talking about has to do with the X39. We call it stem cell activation patch. But the study and the effect of the patch has everything to do with the actual peptide known as the GHK copper peptide. So I'm calling it the GHK copper peptide study. The research here, you can go back and read these. I'm not going to read them right now for time's sake. It was published March 7th, 2021 in the Internal Medicine Research volume. I got to get this out of the way. You'll have to go back and read that. I couldn't see it because of your pictures. So this study was a double-blind, randomized controlled trial that explored the impact of wearing the X39 transdermal photobiomodulation patch over a period of 1 week on the level of GHK copper peptide. Now you see the study. We want to show if wearing this patch elevates that peptide. Here's the cool thing. This research paper was presented to the U.S. Patent Office in order to receive the patent for the X39 technology. That's how groundbreaking and important it was. So this is the process. Started up here, 60 people were randomized into 2 groups. 1 tube of blood was drawn. More blood was taken at 24 hours and 7 days. The result, this is like an overview, a significant increase in GHK was found compared to the control group. So the X39 was worn for a total of 7 days, and they looked at the increase. That's what they were proposing and asking, will it increase the GHK copper peptide? So in order to understand what the patch does, let's turn to PubMed, National Institute of Health, and look at some of the studies that have been done on that peptide. Hold on to your hats. First isolated, 1973 by Dr. Lauren Picard. David Schmidt talks about him very highly and says he should have received the Nobel Prize for the discovery. Maybe he still will. It belongs to a group of what are called emergency response molecules that your body puts out during injury to come to the body's aid. Hey, I got something going on. I'm going to have to repair. I'm going to have to rapidly heal some wounds. I need this. I need that. That's what that GHK copper peptide does. It's naturally sent out to those injured tissues. It has been shown to have a therapeutic role in age-related neurodegeneration and cognitive decline. This is one of the reasons we use them in my practice, which is we help people with brain issues. Improves axon survival. I'll explain that in a second. And maintenance of nerves. We've heard testimonials of people who get great benefit when they have neuropathy, diabetic neuropathy, and other issues going on with nerves. And the axon is the big long part of the nerve, and it helps maintain those and maintains the nerves. Let's see, is my screen frozen? No, okay. So let's talk about some of the actions of the GHK copper peptide. Activate stem cells, that's what we talk about. But that's only one category that this GHK, of the effect that the GHK can have on the body. Accelerates the speed of wound healing. Beneficial for hair, skin, nails, both growth and repair. And here's some subcategories. Tightened loose skin and thickened older skin. Repaired protective skin barriers. Who doesn't want to have the younger looking skin as we age? Improved skin firmness, elasticity, clarity, reduced fine lines, depth of wrinkles, and overall appearance, and smooth, rough skin. More actions of the GHK. I don't know if you've heard this yet, but it's an antioxidant and it's anti-inflammatory. It beneficially altered the expression of human genes, and I'm stating it in the past tense because these are according to studies, and this is extracted from PubMed, National Institute of Health site. Beneficially altered, so genes will either tell the body to do something more or do something less. And so it was about 50-50 activating the genes and to do what they are designed to do. Some of them go up and some of them go down. Induced strong anti-anxiety, anti-aggression, and anti-pain activity within 12 minutes in a study of rats. This is why people in my practice say, wow, I just feel calmer, or this pain went away. Alleviated neuronal apoptosis and intracerebral hemorrhage. Let me explain that. If you have a head injury, you get hit in the head, and you'll have swelling or hemorrhage, bleeding inside of the brain. If you have ample GHK copper peptide in your brain, in your blood, the number of neurons that will die decreases dramatically, which is huge for maintaining yourself, your brain function if you're injured. More actions. It's been implicated in the resetting of 4,192 genes to a younger, healthier state. We talk about that all the time. It resets, you'd be safe to say, about 4,200 genes to a younger, healthier state. It is the #1 bioactive compound recommended for the treatment of COPD. I want to make sure everybody knows this is according to research. I am not making any medical claims, but it resets the programmed cell death cycle in different types of cancer cells. So why are cancer cells cancer cells? Well, they don't get the message when they're sitting there in some tissue. Hey, I got a neighbor on the right, a neighbor on the left, a neighbor in front, a neighbor in back, a neighbor above, a neighbor below. Hey, I don't need to divide anymore. Cancer cells don't get that message. They just keep dividing, and they invade the neighboring tissues, and that's why cancer can be fatal. Well, the GHK reset that cell death cycle in several different types of cancers. It has never been shown, the GHK copper peptide in all of the research since 1973 has never been shown to cause any side effects or issues. So if someone comes to you and they've been using the patch for a day or two or whatever, and they say, hey, this happened. Well, the first thing you want to say that there are no side effects from the GHK. It's your body's inability to do something like detox or to perform something that you haven't been really healthy and you have compromised detox pathways. That's usually the cause of that. It's not a side effect of the GHK copper peptide increase in your blood. More actions. It's being used now to heal spinal segments. And what they do is they do subcutaneous injections of the GHK copper peptide in over areas of the spine that have been damaged, and they've actually been able to heal discs and things. Well, we don't do injections, do we? We just increase the GHK copper peptide systemically, so they have ample in the brain, in the spine, in the kidneys, everywhere in the body, rather than a small injection of a quarter of a milligram of GHK copper peptide subcutaneously. This is a little confusing. I'm going to explain this. Enhanced activity of alginate hydrogels for human cord blood, mesenchymal stem cell osteogenesis. Osteogenesis is the creation of bone, new bone where it needs to be created. These alginate hydrogels, they put this stuff on areas so that it will stay there when they want to cause something to they want to heal something. Well, the GHK enhanced this bone regeneration in these alginate hydrogels, increase the healing speed of many tissues. And we hear these testimonials, you wonder, how in the heck is that happening? Well, it increases the healing of skin, stomach, intestine lining, and bone tissue, to name a few. Few more. You're going to see some slides in a minute that is very pertinent to this. Strongly chemo-attracted, I'm going to explain it, capillary cells, mast cells, and macrophages. Chemo-attractive means, hey, where it says capillary cells. So they are going to infiltrate tissues where they need to go. And it's the GHK that says, hey, over here, come and get me. And then the capillary cells chase it into the damaged tissue, and you get rapid growth of these capillaries. When you have big cuts, lacerations, injuries, there's no blood flow. There's no blood supply. So the GHK strongly chemo-attracted those things, and immune cells, macrophages, they go in and gobble up the bad guys. And mast cells, that's part of the immune response as well. Strongly activated genes of the ubiquitin, here's some more fun words, proteasome system. So we have a system of communication in our body, so lots of them. One of them is to send out some kind of a chemical, a signaling molecule, kind of like the GHK, but it only needs to turn something on and stop. It can't keep doing the thing that the body's telling it, or that your body's trying to tell those whatever it's doing, and so it has to be cleaned up. The ubiquitin proteasome system is used for cell cleansing. So you think about that, cleaning up stuff that we don't need anymore, how that can also promote good health. Here's a biggie. When someone says, hey, I had stem cell injections and they didn't work. And when you know that stem cells are attracted to inflammation, like a moth to a light, but if the inflammation is too great, it's more like a moth to a flame and they die. This is why the doctor has to say, hey, they might not work. It's because of the inflammation that they wouldn't work. Here's why they can't give you cortisone. Cortisone has anti-regeneration properties. So they're not going to give you cortisone to cut down the inflammation. This is why it's so great with the AON and the X39, because the AON reduces the inflammation naturally without cortisone, but the GHK helps block the regenerative effects of cortisone. Last two biggies, especially for me, not that I'm special, but I've had huge changes in heart health. Reduced fibrinogen synthesis. Folks, fibrinogen levels are the top predictor of cardiovascular disease. What else? Increased myostatin gene expression 9.4-fold. Myostatin inhibits heart failure. So now you know the bigger, deeper story on the GHK. Here's a couple of things. If you go to PubMed, you're going to see right here, it says 124 results. There are 13 pages of studies about the GHK. Here's one of them. This has to do with the rapid infiltration and the chemoattraction of the GHK, promoting cell proliferation and angiogenesis. That's creation of new blood vessels. Regenerative and protective actions of the GHK peptide in light of the new gene dating. Go in and read this stuff. So here's the final result. Significant increase of the GHK copper concentration in the blood of the active group was seen in the p-value. You're going to find that out from Dr. Staci coming up. What is the p-value for comparing changes from day 2 to day 7? So the biggest result was between day 2 and day 7, not between day 1 and day 2. This p-value is lower than the standard to indicate significant improvement or significant value, significant results. She'll explain that. Okay, Dr. Staci, We are getting ready to launch. 5, 4, 3, 2, 1. Dr. Staci, you're up for the Alavida patch.
Fantastic. Thank you so much, Dr. Harmon. Well, before you go any further, I would love for you to just quickly share, because I know everyone's on the edge of their seat right now. If you could share the X39 results with your heart, how you mentioned how it is very important. Would you mind to share that with everyone very quickly?
Yeah, without the slides, I'll just tell what happened.
Yes.
Okay. I noticed something weird in my heart when I was young, when I was a teenager. I didn't know what it was. I never told anybody. The doctor, when we would go for our little physicals, they would say, yeah, you got a heart murmur. And that's pretty much it, because I was a kid and they just told my parents. They didn't know either. They weren't involved in healthcare. Your son has a heart murmur. So when I started using the X39 in April of 2020, I just had this idea. I thought, well, not just because I'm a man where we think more is better. You know, if one's good, 13 would be better. No, I thought if I put one in the normal spot and then right over my heart, maybe I could create change. And I had a knee replacement surgery coming up because I was a crazy skier and broke my leg and tore my cartilage in 1973. And I, all of a sudden, about 4 months after I started using the X39, those PVCs got really regular. It's like every fifth beat, day and night. I'm getting worried because I think, man, what's going on with my heart? These weird stuff. It sounds bad, but it was really actually a good thing. So I made an appointment with a cardiologist, and I'm so glad that I did, because I was able to document something that I had that I did not know I had. I had a stress echocardiogram done a couple of weeks before my knee replacement, and he said, after the test, he said, your heart responded well to exercise. I already knew that. I used to run 40 to 50 miles a week. It didn't bug me when I was running. It was PVCs at rest. And he came in and says, you just have these PVCs in this right bundle branch block. And I said, well, what causes that? And he said, well, you know, we get apoptotic cells everywhere. Those are cells that are killed because they're old, sick, and dying. And we're supposed to replace them, but it's difficult to do in the heart. And the light went on for me, and this is what I thought. I have no proof of anything of it. I have ample stem cells now. The cells are being replaced. They don't know how to beat yet. They're getting the wrong message or something. They're not connected. I don't know. They're all beating at the same time. They're all causing this to beat. So 2 weeks later, my PVCs went away. They're not mine. The PVCs went away. But you know what my first thought was when he came in and said, you have this right bundle branch block? My first thought was, well, I've been using these stem cell activation patches for 4.5 months. Why didn't it go away? Why didn't it heal them? But I was persistent and kept using them. A year and a half later, I had another stress echo done, and the results came back, and it says, right bundle branch block no longer present. 2 different cardiologists have said they've never seen one of those go away. And forever grateful I am, my family, because if you have a right bundle branch block, all-cause mortality goes up because anything you have gets worse. So that's what happened. If somebody, first of all, if somebody judges the patches on 6 months of use or a year, I just tell them my story. Don't give up before the miracle happens, because you're increasing your stem cells.
Absolutely. Thank you so much, Dr. Harmon. I knew I could just feel everybody was on the edge of their seat saying, well, what was his heart story? Because heart disease is the #1 killer, and we know that that's huge for people. Obviously, it's impacting everyone on this planet. So thank you for taking the time to share that with us.
You're welcome.
All right, we're going to dive deep into Alavida. So Alavida was originally developed to elevate the peptide known as epithalamin. but we can't really discuss that and the depths of that. But I will share with you, if you do a little research yourself, you will find there are neuroprotective benefits. There are studies out there with this peptide, specifically preventing cognitive decline, being able to decrease mortality in adults with cardiovascular disease, increase melatonin. So it does a lot if you go research just the peptide itself. But we are going to discuss in our study today how our study was done and the effects on the organs, as well as the reduction of oxidative stress. And if you don't know what oxidative stress is, picture an apple when it falls from a tree. It hits the ground, right? It's beautiful as soon as it hits the ground. And as it sits there over time, it starts to decay. And then, of course, it completely decomposes. And so that's what we picture in our body when we see the cells that are damaged with oxidative stress. They should be these beautiful, bright, luminescent cells. And then, of course, damage to them is causing what we call oxidative stress.
And there we go.
Okay, so Alavida, of course, is a non-transdermal patch that improves cellular function in organs, different organs. So we're going to talk about that today with the Alavida. Alavida is a patch you wear at nighttime as well.
And I can't get this too advanced. There we go. Marvelous.
Okay, no worries. We're not in a hurry. So you can see with the research, which doctor it was done, location, things like that. You heard David talked about these Dr. Homer all the time. So basically, this test was done with what's called a bioelectric impedance data, or with that information was coming from an electro-interstitial scanning system, an EIS. So maybe you're familiar with EIS, maybe you're not, but I want to kind of tell you really quickly what that does. So it's about a 5-minute test. It's non-invasive. It's a screening test that measures or calculates the parameters on things like hypertension and sympathetic activity in the body, stiffness of the arteries, body fat, leptin, insulin resistance, things like that. So it's going to measure the physiologic organ function of the organs in the body we're going to talk about next. But I want to also let you know that this is a French electrochemical device. It's classified as a medical device in the United States and in Europe. And so that EIS is what was used to test the effectiveness and the effects on these 12 organs that we have here when this study was done in the Health Integration Institute in California. So we're going to look at the kidneys and all of that, right? So what are the chances? You heard Dr. Harmon talk about the p-value earlier. P-value in testing, what are the chances that something could be random? Because that's a lot of times you hear people are like, well, I put this little Band-Aid on, is it really working? Is it not? What does that mean? And so when we look at the statistically highly significant results and the significant results, we're basically, when we're looking at p-values of where you can see down there at the bottom where it's 0.001, that's like a 1 in 1,000 chance. So the smaller numbers are the greater probability that the results were from what was done in the study and experiment, not just random. So we can show statistically, highly significant results and significant results as well too from these patches. And so when you look at the frontal lobes, adrenal glands, the liver, the hypothalamus, pituitary, thyroid, you all have these parts in your body, correct? We normally talk about this as your part of your endocrine system, obviously your organs. So the test was performed baseline for these participants. They wore them. I really want you to pay attention to this part because I've heard David talk about this when he does deep dives into Alavida as well too. Alavida in this study was done 5 nights. So Monday, Tuesday, Wednesday, Thursday, Friday, and then take it off on Saturday. Don't use it on Saturday and Sunday. So they wore the patch 5 out of 7 nights per week for a 30-day period. Okay. And so that's where this testing is coming from. Typically we put on Alavida, we wear it every single night. But for this study, they did decide to do 5 out of the 7 days. And of course, the EIS was repeated at the end of each week. Highly significant improvement was shown, 0.0001. And there was significant improvements in the kidneys and the pancreas. So again, same thing as far as the testing, but very significant on the kidneys and the pancreas. That's huge. We all have those organs in our body as well too. And then when you look at the intestines, which is on the next slide, it said that they needed more time, or maybe it's on another one, I don't know. But it's, I know it's a little farther down the road, but when you look at the intestines, they need more time in order to determine the effectiveness on the intestines. But 99% chance that the results were not random on the adrenals, the frontal lobes, the liver, the hypothalamus, pituitary, and thyroid. And then again, very significant improvement, 90% chance that they weren't random on the kidneys and the pancreas. So this p-value is very important when you're looking at results, and the chance or the probability that you are going to have significant improvements in your systems, in your body, your organs as well too. And here's where it says the no significant improvement in intestines. Well, that's okay. You're using the X39. We saw great improvements in the intestine, right, with the X39. So it says that we just want a longer period of time to determine the physiological function of the intestines with Alavida. Just that specific patch. Remember, this is only on Alavida. This isn't talking about the other patches, for example, SP6, which we can see improvements in the first 7 days even with that one. So thank you, Dr. Harmon.
All right. Thank you so much. It's kind of fun. You do it more often.
I know. I love it. I love Alavida. Alavida, and I want to share this too. So Alavida is a patch that we wear at night, like I said. It's traditionally promoted for its benefits in the skin, the reverse or anti-aging of the skin, the lines, the wrinkles, the dark spots, the firmness, tightness, stiffness, things like that of your skin, increasing collagen production in your body, which is super important. We're going to talk about that in depth here in just a little bit after you're done with this one. But Alavida has a lot of functions. It signals that peptide in your pineal gland or your pineal gland, depending on how you pronounce that, to be able to do what it does. And so remember, there's nothing going in the body. It's just signaling a different peptide. So X39 signals GHK-cu, and the Alavida signals the epithalamin peptide.
So, Dr. Staci, you probably wear more than one patch at a time, don't you?
I do.
People ask me that all the time, and I say, yeah, I think I have 5 of them run right now. We're only talking about these 4 studies. So, well, thank you very much. That this brain mapping study, it's actually where my board certification is in brain mapping and neurofeedback. And so I hope to give you insight into this. It was done by SciTech Labs. They did a non-invasive scan. It is a non-invasive scanning and subtle energy testing lab. So the effect of the Lifewave X39 patches on the brain, as seen with P3 brain mapping. And we won't get really technical on that, but I'm going to give you some basics about it. Principal investigators, you can go back and read all of those. So I want to explain and define for you a few terms before we go and show their actual brain maps. EEG coherence, electroencephalogram coherence. It's a measure of the synchronization of signals between 2 sites and may be interpreted as an expression of their functional interaction. How are they communicating and sending these electrical messages back and forth? Coherence quantifies the degree of the interaction or communication and shared information between brain sites. Here's coherence. And I put different colors on this side than this side because truly we have 2 separate brains, kind of, in that there are a lot different things that happen on the left side of the brain compared to the right. And that's what the colors represent. But we have this communication back and forth, coordinating with both sides of the brain. Normal coherence is when there's a normal amount of traffic going back and forth. And then we look at, because there's just the right amount. And then we look at this, more of an explanation, when brain sites are not functioning in an efficient, interdependent fashion, they have too much crosstalk, they are overly connected and locked together. That's hypercoherence. So here's I show, got the same thing going on the left as the right. It's not supposed to happen that way. Hypercoherence is too much. There's too much crosstalk. It's like a jammed up freeway during rush hour. Nobody goes anywhere. So everything gets slowed in the brain when there's too much. Hypocoherence is when it's called poor inter-site interaction, and it's an indication of diminished cognitive efficiency. So here would be hypo. It's like nothing, there's not, I don't have much here and much here, and I don't have enough crosstalk to coordinate all parts of the brain. Because truly, I'm sure you've heard this before, but 80% of some things are processed on the left side, some are processed on the right. But the actual facts are things are processed 80% on one side, but 20% on the other. And the same is true for everything. So, but truly, everything is processed partly by the entire brain. It just needs to be lopsided one side to the other and then cross-coordinated. A little bit different look at it. Hypercoherence. Both sides of the brain are struggling to process information, and they basically try to recruit each other and therefore have more brain cells to do the job in processing the same information. Things are jammed up. Hypocoherence, that's where there's not enough communication between sites in the brain, and it implies cognitive processing. So the study looked at, and move that out of the way. Oops, sorry, gotta go back. The study looked at the degree of hypercoherence and hypocoherence. Where is there too much traffic, and where is there not enough in each individual, and how they improved as a result of wearing the X39 patch. So what were they measuring? And this gets a little technical. I'm just going to make it understandable. So I have to get some things out of the way. There we go. So physical reaction time, we looked at that. How long does it take after hearing something to do something? Trail making. A standard measure of brain function includes measures of psychomotor and visual scanning. Auditory P300, what they do is they send in a sound, an audible sound in headphones, and watch how fast those messages go to the places that perceive that sound. And if it goes too fast or too slow, that's abnormal. This CZ theta beta, just know that if their beta waves are involved in concentration and fast processing, theta waves are more like halfway between sleep and awake, meditation, and memory processing. If your theta waves are too overpowering for your concentration beta waves, it's ADHD, it's ADD, it's aspects of autism and Asperger's. These are the things we treat in my office, and the X39 actually facilitates that. F3, F4, this has to do with, there are two of our brain waves that are supposed to be asymmetrically more powerful on one side or the other. They are beta and alpha. When they switch, if alpha switches to the left, more powerful, it's depression. If beta shifts to the right, it's anxiety. Now let's get messing around. Okay, so that's good enough for that. Hopefully that was understandable. Let's look at some results. So here's what the brain map looks like. And all right, so the red is areas of hypercoherence, overactive brain. I can't focus, I can't process stuff. Everything's all jammed up. Blue is hypocoherence. Green is good, good, green, yellow, good. You see, from session 1 to session 2, look what happened. It wasn't a straight line to get to session, the third EEG. It actually kind of overcompensated, and then had some hypocoherence. So this is why it's important to set someone's expectations correctly. As your brain goes through shifts, and we see this in my office every day, where on your way to something good, something kind of goes with a little underfunctioning, but then it goes back. And that's what the researchers stated at the end of the study. Here's another one. This brain is way overactive. Almost the entire brain was in hypercoherence. But the halfway mark, he just had it in the frontal lobes. And now you start to see some green and some a little underfunctioning. And then the whole brain is working better than this on the left. Here's another one. Way overactive brain starts immediately to start getting better function and communication side to side in this one, and then has for the most part green, yellow, blue, but it was only 6 weeks. But this guy had better brain function, better cognitive ability. This one was really interesting because started out in hypocoherence. The entire brain went into hypocoherence before it started shifting. This is a long-term project right here to get this brain. You see a lot, much better functioning here. But the interesting thing that she said that she was feeling a lot better. And we see that when we used to do these brain maps. We don't need to do them anymore with the new system, but we would see small changes in somebody's brain maps, but huge changes in symptoms. So the conclusion of this study, all participants showed dramatic changes in their scalp topographic maps, reporting the amplitude of the P300 recording. So without getting all that technical stuff, the bottom line is everybody had better functioning brain, less hyperactive brain, overactive brain. And some of you, if you have an overactive brain, I can't shut my brain off at night and I'm having a hard time focusing. I can't process things. I don't remember things. I might have anxiety. I might have depression, ADD, ADHD. The more hypercoherent someone has, the more autistic he or she is. Okay, so that was a 6-week trial. So here we go. We're going to move on to the next study. Dr. Staci, you are up. We're going to roll the dice and see what comes up. Oh, it's the X49 bone density study. Cool beans.
Oh, Dr. Harmon, I love your slides. I mean,
you're
just amazing. You're so creative. And I love how they're all so different. So you're keeping us so engaged.
Yeah, you got to keep watching.
What's next? What's next? Okay, so we're going to talk about X49 and specifically with the Lifewave X49 patch and how it supports bone and muscle health in women ages 40 to 80 was this clinical study. So we're going to look at the bone density component of that. So we're going to talk about the different metabolic implications of wearing this patch versus the X39 patch over a period of 8 weeks. So we can see studies using them individually. And you heard Dr. Harmon talk about how that helps, X39 helps with bone, but we also can look at them together as well too. And so those studies, of course, start X39now.com. You will definitely be able to see all of these studies in depth on that website. So we're going to talk about the changes in AHK-cu peptide levels. Okay, that's a different peptide from GHK-cu. It is a daughter peptide, which is why these two patches work so well synergistically together. We're going to talk about the hydroxyproline and the NTX levels as they relate to improved bone density. So in order to understand this process, we must first understand what collagen is and what holds it together and what NTX and AHK-cu. So collagen is like the glue that holds your body together. Basically, we know that you have plenty of collagen up until about age 18 to 20-ish, and then we start to see that decrease in the collagen production in your body. So unless you're doing something to help increase your collagen production, then you're going to find that things are going to start to break down. But we're going to specifically look at these amino acids. So we're going to look at glycine, which is on the top left. It's an amino acid. It acts as a neurotransmitter. It's obviously a component of the collagen. We're going to look at the hydroxyproline, of course, which is as well an amino acid, and a little bit more in depth with it. And proline, which is amino acid that is required for the biosynthesis of collagen in your body. So all this to say, if you look down this graph, looking at the sequence and the amino acids and what's happening, we're going to talk about our collagen fibers. And basically, the hydroxyproline is being one of the components, one of the amino acid sequences. And if the collagen breaks down into the individual, then the components are going to be more prevalent in the blood. So we want to really look at that and what that is, how that's happening with collagen. Okay. So again, collagen holds basically the glue that holds things together. So we're looking at the 5 most common types with your bone, your skin. Type 2 is cartilage. We look at connective tissue, baseline membranes. And of course, it's most commonly known with your estheticians for the hair, skin, and nails, right? The face, what they're doing there in the office. But the structure of the bone is made of collagen. And the ossification process, or the bone formation, starts with the cartilage, okay? And so the next screen, when we look at what happens when collagen breaks down in the bone, we're either going to take some bone or add some bone. So there's a constant give and take from our bones. Bones added if we exercise regularly. Hopefully, you hear us talk about this all the time as part of a healthy lifestyle, is to get moving, whether it's put a YouTube video on and do something in your house, body weight exercises, go for a walk. You know, you heard Dr. Harmon talk about running 40 to 50 miles a week. That is impressive, very impressive. Skiing, which can be dangerous, obviously, but still a lot of great exercise. So bone is taken when we are inactive. And also if we don't consume enough calcium. And so I want you to Google calcium, types of foods that are rich in calcium. A lot of times we think of drinking milk. And I personally feel like there are much better sources to get your calcium. So looking at, you know, your green leafy vegetables, your seeds and your nuts, you know, those types of things, maybe some hard cheeses if you're consuming, you know, dairy or, you know, chickpeas or something like that to get your calcium. So let's look at collagen. Okay, so collagen, when we look at the collagen, like it looks like a braid, right? But we look at the denaturation process, and this happens in the stomach. So this is required for proteins because they need to be digested. So the denaturation process of this is basically, it's modifying the molecular structure, deactivating or untangling the collagen, okay? And so then when we see that it starts to, oh, will you back up for 1 second?
Oh, sorry.
When we see those wavy lines, right, that gelatin, that kind of like protein or antioxidant that's going to protect the cells and in the body, we really start to see this process coming from that of, it's called hydrolysis. And so when we look at the gelatin hydrolysis process, it's basically a water reaction. So it's breaking into pieces peptides. Right. Remember, collagen is different types of protein sources. And so peptides are chains of proteins of amino acids. So that is where we see the end up of the peptides down there. So then we're going to look at the type 1 collagen cross-link. So here's where the study comes into play and where you can really and I'm going to finish up obviously with the deep dive into what happened with that. But basically, when you look at the NTX, the N-terminal telepeptide, that NTX on the left side, that is released when collagen is breaking down. So there is more in the bloodstream when osteoclasts are active and someone is losing bone density. So that may be like, way over your head, it may be a lot, or it may make perfect sense. But basically, the NTX is going to connect to strands of collagen. You saw the strands of collagen, right? When the collagen is destroyed, there'll be more of this in the blood. So there's an increase in NTX, or the N-terminal telepeptide, during bone loss. And so then there's this buildup phase. There's a decrease in AHK-cu copper peptide. So why is there less of the AHK-cu? Well, because it's needed in the process of building bone. So the blood levels of the hydroxyproline goes up when bone is being lost. This study was done by measuring the blood, correct? So we can see that. And so in the study, the levels of the hydroxyproline went down. So we're always in a constant state of change in our body. That's a given. At any second, right? There are trillions of things happening. So when you look at AHK-cu, there's less AHK-cu peptide in the blood during the osteoblastic activity. So osteoblastic activity is where the cell secretes a matrix for bone formation. Okay. And so then the NTX, there is more NTX in the blood during osteoclastic activity. And that's when the bone cell absorbs bone tissue during the growth and healing. So we're seeing an increase in bone density and losing bone density. So when we look at the hydroxyproline, there is more in the blood during that osteoclastic activity, decreasing bone density. Now, here's the results of the study. And again, you can see the study on startx39.com, startx39now.com, just as you can the others. But basically, there's a decrease in the AHK-cu and decrease in NTX. There was a decrease in the hydroxyproline. So these strongly suggest that the X49 decreases the breakdown of bones. So less AHK suggesting more bone production. So X49 increases net bone production. And there was less NTX suggesting less bone breakdown. There's less hydroxyproline suggesting less bone breakdown. So that's very important. You want to keep the bone you have, and you want to increase your bone density. Obviously, we talked about exercise. We talked about food. Nutrition is important, but it's also important using the X49 as well because of what we found in our clinical studies to help increase that bone density and reduce the amount of bone loss in layman's terms. So I'm right with you, Dr. Harmon, when you said that. Now I'm 25 right now. I'm actually 48, but since I was young, I have always said that I am going to live to be at least 150, 200 years old, and I am never going to age, and I'm going to feel amazing. I've said this my whole life, and even here recently in the last maybe 3 to 5 years, people always joke because I always say I'm 22. Oh, I'm turning 23 next year. Oh, I'm going to be 25 forever. And then of course, Lifewave enters my life 2 years ago. And I'm like, see, I told you I'd be 25 forever. I'm right in alignment with you 100%.
That's awesome. And man, I just want to thank you for reaching out a couple of months ago and being able to present this information together, because Dr. Staci and I had a discussion about this, and we truly believe that a rising tide raises all ships, excuse me, and a better educated group of branding partners, we are going to present ourselves better to the public and stay away from diagnosing or treating, pretending to treat things. We will keep that in perspective and keep out of the FDA's, list. I almost said the S word list. But you don't want to do that. And so we try to help people understand how they work and what we can say, what we shouldn't say. And I'm really glad that everybody tuned in today. It was good to be back. I haven't been on one of these for a long time. And so we'll see on the next go around and go forth with this deeper conviction. We hope that's been our intention in David Schmidt's goal of 1 billion homes.
Absolutely.
See you next time.
Dr. Harmon, I wanted to say also, you haven't been on here in a little bit, but when I got started 2 years ago, I watched every single thing you did. I read everything, every slide. I was the one screenshotting my phone of every single slide you had. Your information is always so thorough and concise and very easy to understand. And so I learned so much from you, obviously, and David, watching everything that he has. But I learned so much from you in the beginning and started really diving into those studies because you reference them so much. And I think that's really important, that we listen, we learn, and then we also take that information and continue to learn and grow from there and doing our own research. And maybe you're not a reader and a researcher. You don't have to understand these clinical studies to see significant, highly significant improvements in the functionality of organs and systems, cells, bone in the body. It's just showing that we actually have products that are doing something pretty significant in the body, making a difference in how people feel their quality of life. And that's really what we're here for, is to make sure that we're helping people, adding value to their life. So you definitely have added so much value to my life, Dr. Harmon. I'm so grateful for you saying yes. I know you're so busy in your practice, and you have so many people that you're helping to take care of with these amazing patches and what you do, so many different things in your practice. So thank you for taking time out today over the last 2 months to go over these studies with me and to create those slides for everyone, because we're so grateful. We had over 400 people on here today at one time when I looked down, and they're already, of course, asking for the recording. How fast can they get it? Yeah. So we'll have that up right away.
Well, thank you so much for your kind words. It was a lot of fun. And I learned whenever I do a slide presentation or prepare the slides, I have to understand it well enough in order to get it into a presentation form. So it helps me as too. That's my payoff. Mm-hmm. And the other payoff is everybody has correct information. So yes. Yeah, thank you for reaching out.
Absolutely. Thank you. Thank you. Well, I'm going to stop our recording now because I do have an announcement to make here real quickly. But thank you again, Dr. Harmon, for partnering with me on this today.
Absolutely.